Split models or split population modeling is another technique that allows the user to build multiple models, which can then be combined to create a single prediction. The idea with split modeling is that if the data represent different populations or contain separate groups that behave in very different ways, assuming that a single model can explain all the inherent variability across these distinct populations might be unreasonable. In which case, why not build separate local models for these key segments and aggregate the resultant scores with the aim of increasing overall accuracy? Let's take a look at how that can be done. Once again, we're using the same dataset and the same algorithms that we used in the previous example. And again, to refresh our memory, let's just build our best standard model that we've come up with thus far, which is a neural network predicting customer churn. And if we check the error level associated with that, we'll notice that we have 1,191 misclassifications. So that's a number in the test group that we're trying to minimize, of course. Now, when we were building one of the other models using the C5 decision tree algorithm, C5 decision tree algorithm, as with all decision trees, will work with categorical data. And browsing the results of that model, we're able to see that one of the most important fields is the handset field. And in fact, the handset field is shown here in the decision tree. And what we notice from that is it's actually grouped handsets together that have a similar level of churn, and that are not statistically different from one another, if you like. And it's actually come up with 4 different groups. One of the things that occurs to me is that these 4 separate groups of handsets might represent 4 distinct populations. Perhaps they're much older handsets and some of them are smartphones and some of them aren't. In which case, is it possible that separate models could be built for them? Now, in order to create these 4 groups, I've actually already done that using this reclassify node. You can see here that I've created handset group number 1, where I'm grouping together these handsets, and handset group number 2, I'm grouping together these other handsets. And that just leaves me with 2 handsets out on their own, which is this one S50 and this one BS110. So we effectively have 4 groups here, and there's a healthy number of cases in each group, so that makes it reasonable to build a model against. Now, if I want to use this this new field, handset group, as a kind of a split field to build separate models, all I've got to do is connect it up to a type node, which allows me to control the role of different fields. And you can see handset group is going to go in here as an input. If I change this to split, it means that the model will be built taking account of the different handset groups, and will actually create 4 separate models. So to illustrate that, if I just make a copy of the neural network node here and then run that to create a neural network model, one of the things you'll notice is that when it creates a model, it's got this extra little symbol here indicating that it has in fact created a split model. And if I double click on it and look inside it, there isn't much to see, but it's actually telling me how accurate the model is for each of these separate groups, both in the training and testing accuracy. So the idea is that it's created local models for each of these handsets, handset group 1, handset group 2, BS110 and S50. And when we combine them together, hopefully it'll be more accurate than simply creating one global model for all the handsets. We hit run at this point, and we see now that the accuracy level is now, we've got 1,098 misclassifications, as opposed, of course, to 1,191. So it's nearly 100 fewer misclassifications as a result of creating a split model.